Hello and welcome to all my traders and programmers out there. My name is the Trading Savage, and today is going to be part 2 of the Schwab API series. We are going to be going over how to create a refresh token system. So basically, use your refresh token to get a new access token every 29 minutes. This is a foundational part of the Schwab trading bot system. And I'm going to get you one step closer to creating your automated trading bots with the Charles Schwab APIs. So let's get into it. But first things first, please note, this is the second part of the series. So the first part goes over how to get the initial authentication tokens, and that is necessary to do this part. So if you haven't done that yet, please do that first and then come here. So I'm going to make a new Python file just called refresh. I'm going to actually stop this from running in my terminal. Now I'm going to go to my article here, and I'm going to copy my refresh token script. I'm going to paste this here. Like we did before, I'm going to right here add request to use functions framework. And I'm going to add some of the functions from helpers, these ones here. Get my CS app key dictionary, which we're going to need. And as before, I'm going to bring these two over. So this will call the app key and app secret from Google Cloud. Now, refresh token value, your current refresh token. I'm gonna go into helpers, and I'm gonna use this retrieve firestore value function. Collection ID, document ID, and key. So collection ID and document ID, we have those over here. And the key. So this key is going to be let's see what the key is for our token, for our access token. Well, no, we're going to grab our refresh token here. So refresh underscore token. Now let's see if this works. Refresh token value, let's get this from console. And we got the refresh token value. So now the last part is we need to overwrite the refresh tokens in Google Cloud. So I'm going to go down here to logger debug token dex, refresh token dex. I'm going to overwrite this with store firestore value, this function. So now store firestore value, we are going to, for the value, put in refresh token dex. So now we're going to overwrite these tokens with the refresh token dictionary. So basically start with the initial authentication token dictionary, then every 29 minutes you overwrite it with the refresh token dictionary. After 7 days, then you need to run the initial authentication again. Use the initial tokens dictionary, then you can start this process again, getting the refresh token dictionaries, overwrite it, and then overwrite it again every 29 minutes. So that process basically repeats itself every 7 days. So now I'm going to run refresh tokens. I'm going to copy this over to my refresh.py. And I'm going to tweak it a little bit. So this is going to be, source is going to be refresh.py. And target is going to be refresh tokens. And yeah, so the target is just the function name. So I'm going to copy this, and I'm going to run this in terminal. And just for good measure, I'm going to activate our content environment. Okay, let's run refresh tokens. I'm going to click on this. And you can see the token dictionary refreshed. So if it works, you're going to see a new batch of tokens in there. And as you can see, the tokens refreshed correctly, and it works. So one more point on the using Firestore to store your tokens. Firestore is technically not the most secure, but if you use other solutions like, overwriting your token dictionary and secret manager, it's going to add up costs considerably, because the secret manager charges you every time the secrets are overwritten. So I tend to go with Firestore just to store those values in the cloud. Then what you can do is we're going to deploy these we're going to deploy the script in the cloud. So there's only one script that we can really deploy, and that's the refresh token script. And we're going to make this a cloud function in Google Cloud so that we can automate this. So in order to do this, we're going to need to create a cloud build.yaml file. Now this cloud build.yaml file is going to be what we use to tell Google Cloud how to create our cloud function. And cloud build.yaml essentially will look like this. Steps, use the Google Cloud SDK. You're going to use the functions product, deploy, and then let's call this function refresh tokens. Entry point, we're going to say, this is the function name, so this is going to be refresh tokens. Region, for me, I'm in California, so I'm going to use Oregon, US West 1. Source is going to be just the period. So, just the root directory is going to be where we find our Python file. If this is like in a subdirectory, then you would do something like helpers folder. So that's, indicating it's in the helpers folder. But for me, since it's in the root directory, I'm just going to keep the period there. I'm going to use Gen 2. So second generation cloud functions allow for 60-minute runtimes. Generation 1 cloud functions allow for only 10-minute runtime. So I'm going to use Gen 2. And I'm going to use Python 3.12 for this. Now, memory is important. I'm going to keep it at 256 megabytes for that container or for that cloud function. And then the next thing we need is we're going to need a requirements.txt. So for every cloud function, you're going to need a requirements.txt. I'm going to create one here for the refresh tokens. So, okay, so one key is that Google Cloud will look for a Python file called main. So we're going to need to change our Python file's name from refresh to main. So first I'm going to just call this initauth for initiate authentication. And then for refresh, I'm going to rename this to main. Now that we have main, this is going to work. It's going to be able to identify that the refresh token here is in main, and that's the function that we want to run. So now I'm just going to create that requirements.txt file. So I just created the requirements.txt. Now I'm going to bring over the requirements for the refresh token script. Okay, so we have this. The next thing we're going to do is we are going to build our Google Cloud function second generation. So in my terminal, I'm able to get the Google Cloud CLI. So if I just type gcloud here, it shows me, my options. So I'm going to be able to use this. And I'm going to say gcloud builds submit config cloud build.yaml. It says API cloud build is not enabled on project Schwab API demo. Would you like to enable and retry? So it says requested entity was not found. No. Default cloud build service account or user specified service account does not have access to the bucket. So I'm going to need to add the cloud build API. So I have cloud build API. I'm going to go to my identity and access management, and I'm going to see what we need to do here. Let's see, cloud build admin. I'm going to try adding the cloud build service account to this. So as you can see, it's basically building my cloud function via the Google Cloud CLI, or command line interface. And what I needed to do is just add this cloud build service account permission to our compute service account, default compute service account. And that'll give basically that service account access to build the cloud function for me here. The best practice is keep your permissions for the cloud function or for the service accounts as minimal as possible. So, try not to give these permissions if you can. Now it says Cloud Functions API has not been used in project Schwab API demo before, or it is disabled. So let's also add this API as well. And I'm going to add this to our identity access management. I'm going to add this Cloud Functions admin role. Now let's try to rerun this build. So as you can see here, yeah, it says the Cloud Functions API has not been used, or it was disabled, it was authenticated by, or it was, attempted to be used by this compute service account. So we need to add one more API. So I think this is going to be the Cloud Run API. And this is because second-gen Cloud Functions rely on the Cloud Run architecture. So I'm going to go back to Identity and Access Management. I'm going to add the Cloud Run role to Cloud Run admin role to our service account. And let's retry this build. Okay, so one more thing we have to enable is when we look at our logs for the Cloud Run application or Cloud Function, we are seeing an error, and it's saying basically secret manager versions access denied for the resource, or it does not, or may not exist. So what we need to do would be we need to add secret manager access to our service account. That way, we're not going to receive this error, and our Cloud Function is going to be able to access that resource. So I think it's going to be secret manager, secret accessor. Now we're going to run this one more time. Run that build one more time and see what happens. While we're waiting, we can enable the Cloud Scheduler API. And click Enable. And we're going to use this very soon to invoke our second-gen Cloud Function. Okay, it's done. That is the best news I've heard all day. So, this build was finally successful. Let's take a look at our Cloud Function called refresh tokens. It's live and ready for use. Now, let's open this in a new tab. Now, I'm going to need a new one more permission, I believe, for my service account, which is going to be Cloud Function Invoker. Ability to invoke first gen. Oh. So we're going to use Cloud Run Invoker instead, because second gen Cloud Functions are basically Cloud Run apps. Save those changes. Okay. Now, since we have the Cloud Run Invoker, we're able to use this compute service account to invoke the Cloud Run application. So I'm going to now schedule a cron job, and this is going to basically schedule our refresh token cloud function to run every 29 minutes. I'm going to say schedule token refresh for the name of the schedule. I'm going to use Oregon, and I'm going to say every 29 minutes, every hour, every day, every month, every day. Time zone, I'm going to use United States, and I'm going to use Pacific. Now, target type, HTTP, I'm going to use get method. For the URL, I'm going to bring over the URL of this cloud function. Now, I'm going to use a add OIDC token so I can specify which service account I want to use. That's going to be the default compute service account. For the attempt deadline, I'm going to say 30 minutes. That's the maximum. Now we've created our first cloud schedule job. Let's give it a shot right now and see what happens. So this is going to be running every 29 minutes. But let's see, next run doesn't have anything there. I wonder why that is. So let's force run this. And let's take a look at our logs. So you can see the Cloud Run app was initialized, retrieved the refresh token value, updated the refresh token value, and let's take a look at our Firestore to make sure the tokens were refreshed. Okay, so our tokens were refreshed. We have the same refresh token, but a new access token. We're going to need to keep this up every 29 minutes. So in order to be able to access the APIs. And this is basically the foundation for all of the Charles Schwab APIs. So, if you want to run those in the cloud, it's a pretty similar process. Create the Python code, requirements, add it to the cloud build YAML file, and from there, once you build it, you can schedule it with Cloud Scheduler, grab the access token from the Firestore, for your execution in order to access those APIs, and then from there, you can do whatever you want with the Schwab APIs. So this is absolutely key. This is the foundation. And then every 7 days, like I mentioned, you're going to need to run this initial authentication code right here to actually go in, log into your Schwab, approve that account for API access, and keep that up every 7 days. So that is basically what I use for my trading bot. And once you've gotten this far, you're in great shape to basically, get that bot up and running and fully automate the process in Google Cloud, except for that every 7 day login. And that is all for this tutorial. I hope that you found this tutorial helpful, and please drop me a like and subscribe. I'm going to have a lot more content in the future related to trading bots, and so forth. So thank you all, and until the next video.